What we're going to do today is solve rational equations, and we're going to use a strategy very similar to what we did yesterday when we added or subtracted rational expressions, which is focusing on the LCD. So a couple things. A reminder, an extraneous solution is a solution of a derived equation that is not a solution of the original equation, meaning when you substitute that value in, it doesn't work. Most common scenario is it gave you 0 in the denominator, and we saw this with radicals when it gave us a negative value in our radicand. Now, what are our steps going to be? Step 1, we want to find the LCD, least common denominator. Then we're going to multiply the entire equation by the LCD to eliminate all denominators. The key here is that what makes a rational equation more difficult than a regular linear equation is that we have denominators, we have fractions, and we'd like to eliminate them. We're then going to solve that resulting equation, which will be usually a pretty straightforward linear equation, and then we're going to check to make sure that there are no extraneous solutions. Okay, so I have 1/12 plus 1 over y equals 1/4. Okay, so hopefully you realize that the LCD in this case is 12y. Now I'm going to multiply all three terms by 12y. One of the things I recommend is doing that off to the side here, because when you try to do it within the context of the original equation, it really does get messy. And it's not a question of understanding or knowing what you're doing. It's just a question of trying to keep things organized. So when I do this, I get y, I get 12, and I get 3y. So what I'm left with is a very straightforward y plus 12 equals 3y. Now I'm solving my linear equation. So I get y is equal to 6. The only place where this could have been a problem is obviously where y is in the denominator here, and then that is not a problem. The only difference between what we're doing today and what we did yesterday is we are not creating least common denominators. Now, some students see it where they create a denominator of 12y throughout. Well, if you do that, what you're going to be left with in the numerator are these three terms, and you could just ignore the denominator. Okay? All right, next one. My LCD is 6y. So I'm going to multiply everything by 6y. Again, I'm going to do this off to the side. So when I do my canceling, I'm left with y, 2, and I'm not 2, but 4, because that's a 2 here. 2 times 2 is 4, and 33. So what am I simply left with? 33 minus 4 equals y, or 29 equals y. And again, no extraneous solution. I go to the next page. Now, this is a little trickier. My LCD, I have an x minus 2 and an x. So remember, as we saw yesterday with the, I think it was d minus 1 and d plus 2, my LCD would be x times x minus 2. I don't want to multiply or distribute to get x squared minus 2x. And the reason is as follows. When I now do my canceling, I'm getting rid of x minus 2. So I'm left with x times x, which is x squared. I'm getting rid of the x, which means I'm left with x plus 2 times x minus 2. And then I'm not getting rid of anything, which means I'm left with 2 times x minus 2. It's just much easier to deal with not multiplying out the x times x minus 2. Now I'm going to multiply out. Okay, so be careful here. It's 2 times x, which is 2x. So I'm really distributing 2x to x, 2x squared, and 2x to negative 2, which is negative 4x. All right, I have a quadratic right now, but once I get rid of the 2x squared, I'm left with negative 4 equals negative 4x, or x is equal to 1. I don't have any extraneous solutions because I don't have any zeros in my denominator. Okay? All right. Next one is going to be very similar. My LCD is going to be x times x minus 1. So I'm going to multiply each one of those by that. That cancels. This gives me x squared. The x cancel. That gives me 2 times x minus 1. And that gives me just an x. Okay? So I want to clean this up. Not a plus, but an equal. I have a quadratic, so I have to set it equal to 0. I factor, and I get x is 2 and 1. But then I notice that if 1 is substituted in, it's extraneous. So really, my solution set is just 2. Okay? The next two, just scroll down. All right? I'm just going to work off on the side here. My LCD here is 10. So when I do that, I'm going to get 6x plus 15 equals 7x. So that 15 is equal to x. No extraneous solution. And over here, my LCD is 6. So I'm going to get 2 times x minus 3 plus 3x equals 24. Just one step ahead of myself. 2x minus 6 plus 3x equals 24. 5x minus 6 equals 24. 5x equals 30. And x equals 6. No extraneous. And I am done. So the key couple of things here are, number one, you want to get rid of all these denominators to get yourself a nice simple linear equation. Two, the most important thing, every term of your equation is getting multiplied by this LCD. Okay? Otherwise, the equation doesn't stay balanced.